Hi everyone. I'd like to give a short overview, essentially a sketch of what's going on when you try to prove Arrow's impossibility theorem. So as a reminder, Arrow's theorem says, suppose that there are at least 3 candidates and finitely many voters, and now consider any social welfare function. So remember, what a social welfare function does is given a profile P. So a profile P is an example, an election in which each voter submits a ranking over the alternatives. A social welfare function is a function f such that it assigns to this profile P some ranking. So f of P is a ranking over the alternatives. So it's the output, it's society's ranking over the alternatives. So any social welfare function that satisfies universal domain means that the function has to apply to any possible profile, satisfies independence of irrelevant alternatives, or IIA. That means the relative ranking of A and B depends only on how the voters rank A and B and nothing else. Pareto, it also satisfies Pareto. That means if all of the voters rank A above B, then society must also rank A above B. So if you have a social welfare function that satisfies universal domain, IIA, and Pareto, then it must be a dictatorship. That means it violates anonymity in a very strong way. That means there's a single voter such that in any profile whatsoever, if that voter ranks A above B, then society will also rank A above B. Now, I'm not going to go through a full proof of this theorem. If you're interested in looking at proofs of this theorem, I can recommend either this textbook by Wolf Gartner or maybe this nice article by Gina Koplos, where he talks about different ways of proving Arrow's theorem. But rather than doing a proof, I just want to give you a sense as to why Arrow's theorem is true. Like, what is it about those 3 principles, universal domain, IIA, and Pareto, and the fact that we're working with social welfare functions, so that the output, the ranking, the social ranking must be transitive? What is it about those properties that conflict with each other? So in order to do that, we're going to consider 2 different profiles, P and Q. So one thing about what I have written up here, the 1 and 2 here in this profile, those represent voters. So this means voter 1 submitted this ranking. This means voter 2 submitted this ranking. And so 2 also in this profile Q submitted the ranking C above B above A, and over here in P also submitted C above B above A. Voter 1, however, submits different rankings in profile P than in Q. So in profile P, voter 1 ranks A above B above C, but in Q ranks A above C above B. So just some notation, we will write, for example, that voter 1 ranks A strictly above C. That means voter 1 ranks A above C, and in Q, for example, voter 2 ranks B above A. Now, consider profile P. So this is my profile P. We can ask what type of ranking. So imagine we have some social welfare function f. And let's just imagine that that social welfare function assigns to this profile, assigns the ranking B is ranked above A, B is ranked above C, and A and C are tied for 2nd place. So this is my profile P. This is society's ranking. So this is the ranking f of P, where f is my social welfare function that I don't know anything about except for the fact that it satisfies universal domain, IIA, Pareto, and it always outputs a transitive ranking. So what I'm going to show you is that it is impossible for society to assign the ranking B above A and B above C, and A and C are tied. And we're going to do that by considering a 2nd profile, namely Q. So here we have P, and this is my profile Q. And we're going to ask, what do the conditions IIA, Pareto, and so on require my social welfare function f to assign what does it require for the ranking f of q, right? What is society's ranking given the profile q? Okay, so the first thing that I want you to note is that the ranking of A and C is exactly the same for both voters in both of these profiles. So society's ranks, voter 1 ranks A above C and voter 2 ranks C above A. The same thing holds in profile Q. Voter 1 ranks A above C and voter 2 ranks C above A. So IIA says whatever society's opinion is in this profile P, that has to be the exact same opinion that society has in profile Q. Because the voters' ranking of A and C is exactly the same in both P and Q. So what that means in particular is that society has to be indifferent between A and C. Since society is indifferent between A and C and P, and we're in Q, and the relative rankings of A and C are exactly the same for both voters, then society must be indifferent between A and C in this second profile. So that's what we have. Society must be indifferent between A and C in the second profile. Let's look at something else. Now consider A and B. Notice society's ranking of A and B is exactly the same, or I should say the voters' ranking of A and B is exactly the same in both profiles. So in both profile P, voter 1 ranks A above B and 2 ranks B above A. But in profile Q, 1 ranks A above B and 2 ranks B above A. So both voters' rankings of A and B is identical in both P and Q. What that means is society's ranking of B versus A must match what its ranking is given profile P. So since we assumed that society ranks B above A in profile P, it has to rank B above A in profile Q. Okay, so we now have society ranks B above A and is indifferent between A and C. What that means is by transitivity, society has to rank B above C. So these two were derived using IIA. And so what that means is that B is ranked above A, but we know that society thinks A and C are tied, or you're indifferent between A and C. So by transitivity, you have to have that B is ranked above C. So basically, I just argued that IIA and the assumption that your social welfare function always outputs a transitive relation, I basically have just argued that society's ranking in this profile Q has to match what its ranking is in profile P. That is, society has to rank B above A, B above C, and treat A and C as tied. Now, I claim that this is a problem. So what's the problem? Well, over here in profile Q, everybody ranks C above B. So all of the voters rank C above B. But by Pareto, that means society has to rank C above B. But we just argued by transitivity and IIA that society has to rank B above C. So that's impossible. You now are in a position where Pareto's telling you that C has to be ranked above B, but IIA and transitivity told you that B has to be ranked above C. And you can't have both of those properties. You can't say C is strictly preferred to B and B is strictly preferred to C. That doesn't make any sense. So this tells us that there's something wrong. So all we did was assume IIA, Pareto, universal domain, because we assumed that the social welfare function does assign some ranking to this profile Q. So what is wrong is this means that we couldn't have originally assigned B above A and C in this original profile P. My social welfare function has to assign something different to this profile. And to get it, so this shows you that there's a tension between IIA, the fact that the output, the social ranking is always transitive, and Pareto. So there's this tension here, and it restricts what rankings you can assign to some profiles. In fact, it restricts it so far that the only ranking we could coherently assign to this profile is going to be one that just copies what voter 1's ranking is or copies what voter 2's ranking is. So we either treat voter 1 as a dictator or we treat voter 2 as a dictator. That's going to be the only ranking that IIA, Pareto, and the fact that the output is always a transitive relation would allow us to assign to this profile P. So that's the basic idea. This gives you a sense of what's going on in Arrow's theorem. Again, this is not a proof of Arrow's theorem, but it gives you a sense of why these conditions, universal domain, independence of irrelevant alternatives, and Pareto, force a dictatorship on you. So it forces your social welfare function to not be anonymous.